Recent scientific papers have unveiled a startling discovery regarding the interstellar visitor known as 3 Atlas. At a precise distance of 2.1 astronomical units from our Sun, 3 Atlas initiated the release of hydrogen cyanide, an imperceptible yet lethal gas. This phenomenon is termed outgassing by scientists. However, what they are withholding is the extraordinary nature of this event. Comets do not simply hold their breath and then expel poison at a specific predefined distance. Yet, Atlas did precisely that. Concurrently, NASA's crucial asteroid detection probe inexplicably ceased communication, its vital data from the closest flyby vanishing from public accessibility. Is this mere chance or a deliberate concealment? Tonight, we expose the truth behind this communication blackout and what it was intended to obscure. Remain with us until the conclusion, for the cover-up terminates today. If these enigmas captivate you as much as they do me, please engage the like button and subscribe to ensure you don't miss subsequent revelations. As this narrative continues to unfold, share your thoughts in the comments. Where are you viewing from? What is the current time in your locale? And do you believe we're receiving the complete picture of these discoveries, or merely a curated version? To aid in disseminating this vital information, kindly share this video across X, Facebook, Reddit, or even within your private group discussions. Your engagement is the driving force behind this pursuit of truth. We extend our gratitude for your unwavering support. Part 1. The ignition of the poison. Envision this scenario. You are an astronomer meticulously scanning the night sky, observing what you perceive to be just another celestial body composed of ice and rock, originating from beyond our solar system. Then, one morning you receive data that halts you in your tracks. The celestial object under your surveillance, one that has traversed the vastness of space silently for years, has abruptly begun expelling a molecular cloud of hydrogen cyanide into the void. Not in a gradual, predictable manner, but all at once, as if a switch has been activated. This is not conjecture, it is confirmed scientific observation. On September 14th, 2025, the James Clerk Maxwell telescope detected the emission of hydrogen cyanide from 3 Atlas at a distance of 2.13 astronomical units from our Sun. The confidence level of this detection exceeded 5 sigma, signifying that the probability of this being a false positive is less than 1 in a million. The measured production rate was 4.00 plus or minus 1.7 multiplied by 10 to the 25th power molecules per second. This is not a typographical error. We're discussing quadrillions upon quadrillions of cyanide molecules being released from this object every single second. Now, before you assume my intention is solely to alarm you, allow me to elucidate the nature of hydrogen cyanide. You're likely familiar with it. It is the compound responsible for the characteristic bitter almond scent found in certain seeds. It has also been employed as a chemical warfare agent in some of history's most tragic episodes. Within the human body, it impedes cellular respiration at a molecular level, leading to suffocation from within, even while breathing appears normal. However, here lies the crucial point. Hydrogen cyanide is also a naturally occurring component of comets. Many comets harbour it, locked within their icy cores, and it is gradually released as they warm while approaching the Sun. Therefore, its detection is not inherently cause for alarm. What is cause for alarm is the timing and the method of its release. Examine the timeline. Astronomers observed 3 Atlas throughout August of 2025, when it was situated at a greater distance from the Sun, colder and purportedly less active. The James Clerk Maxwell telescope focused its instruments on Atlas on multiple occasions during those weeks. They specifically sought emissions of hydrogen cyanide, employing identical frequencies and detection methodologies, and they detected nothing. Not a trace. Not a single molecule. The spectral data returned was flat, devoid of any signal, silent. Then, mid-September arrived. Atlas had moved slightly closer, now situated at 2.1 astronomical units. the telescope re-examined the object using precisely the same methods. Suddenly the signature of hydrogen cyanide blazed into existence. Not a gradual increase, not a slow trend of warming, but an abrupt activation. Consider the implications of this. Imagine observing a dormant volcano. For months it remains cold and inactive. Instruments register no thermal anomalies, no gaseous emissions, no seismic tremors. Then, one day, without any of the typical precursors indicative of magma movement or crustal strain, it suddenly erupts. You would naturally question what triggered such an event, wouldn't you? You would suspect that something unusual had transpired deep within the Earth, some mechanism beyond your comprehension. This is precisely the situation we find ourselves in with Atlas. Typical comets exhibit gradual release of volatile compounds as solar heating intensifies. Water vapor is observed first, followed by carbon monoxide, and then other compounds in a sequence dictated by their sublimation temperatures. Atlas entirely disregarded this established pattern. It transitioned from a state of complete dormancy to actively expelling one of the most toxic substances known to chemistry. And it accomplished this at a distance where most comets are merely beginning to show signs of activity. I urge you to contemplate a possibility that initially sounds preposterous until you truly give it consideration. What if 3 Atlas is not merely a passive icy body adrift aimlessly in space? What if it is an engineered dormant probe, designed by an unknown entity or intelligence, intended to activate at a specific proximity to our star? What if the emission of hydrogen cyanide is not a consequence of random sublimation, but rather a deliberate release, or perhaps even the exhaust signature of internal systems coming online? I understand the initial reaction is to dismiss this as conspiratorial thinking, but I implore you to persevere with me. Over the next hour, I will guide you through a series of events, anomalies, and instances of withheld information that, when pieced together, paint a picture far more extraordinary and unsettling than that of a simple comet. We will investigate why NASA's Psyche spacecraft inexplicably went silent during the precise period when it should have captured the most revealing images of Atlas. We will examine the enigma of its vanishing tail, a phenomenon where Atlas exhibited an anti-tail pointing towards the Sun, an event that defies fundamental physics. We will delve into the reasons why the European Space Agency is withholding spectral data from their Mars orbiters, releasing only low-resolution imagery, while claiming months are required for analysis that should be straightforward. Furthermore, we will conduct a direct comparison between Atlas and a conventional comet, Comet Swan, to vividly illustrate the sheer peculiarity of Atlas. By the conclusion of this presentation, you will comprehend why certain researchers are quietly posing questions that most scientists are hesitant to address publicly. These questions pertain to the potential artificial nature of the object, undisclosed agendas, and whether humanity is being subtly prepared for a revelation it is not yet ready to confront. But first, we must understand what transpired during that silent week. For while Atlas was initiating its release of toxic gas, something highly unusual was occurring with our spacecraft, suggesting a deliberate effort to prevent close scrutiny of this object, and it is here that our investigation truly commences. Part 2: The Silent Week. Psyche goes dark. NASA's Psyche spacecraft commenced its journey in October of 2023 with a primary objective that appears quite straightforward: to travel to the metal-rich asteroid Psyche, which orbits between Mars and Jupiter, and to analyze its composition to gain insights into planetary cores. Essentially, it is a mission of exploration for mineral resources, equipped with multispectral imaging capabilities, a magnetometer, and a gamma-ray spectrometer. However, Psyche's relevance to our narrative lies in its trajectory and instrumentation, which grant it the capacity to observe other celestial bodies within the inner solar system. While not exclusively designed for asteroid or comet detection, if an object of interest enters its field of view during its cruise phase, Psyche is fully capable of capturing it. And in early September of 2025, Something remarkably interesting was poised to enter its observational range. 3A Atlas reached its closest proximity to Psyche's orbital path around September 3rd and 4th. The geometric alignment was nearly optimal. Atlas would have been sufficiently luminous, sufficiently close, and positioned in such a way that Psyche's instruments could acquire detailed observations, potentially resolving surface features or coma structures that ground-based telescopes could not discern. This was the critical window. This was the period when we should have obtained our clearest perspectives of Atlas from a spacecraft's vantage point, but instead we encountered silence. The Psyche mission maintains a public repository of data, where processed images are regularly uploaded. Researchers, journalists, and space enthusiasts can access these observations, tracking the spacecraft's progress and its various operational tests. A careful examination of the timestamps within the image files reveals a peculiar anomaly. There is a distinct gap. From September 1st through September 7th, 2025, the archive displays no images, none whatsoever. Not a single observation is logged, no calibration frames are present, no engineering test shots are recorded, nothing. The spacecraft effectively went dark for an entire week, encompassing precisely the period when Atlas was at its closest approach. Now, before drawing hasty conclusions, let us consider the conventional explanations. Spacecraft do not operate continuously. They undergo scheduled periods of inactivity for instrument resets, software updates, and telemetry transmissions when the deep space network antennas are directed elsewhere. Occasionally, spacecraft enter a safe mode if a minor computer issue arises, temporarily disabling non-essential systems until ground controllers can diagnose and resolve the problem. Sometimes, data processing is delayed, and images acquired during a specific interval may not appear in the public archive for weeks, pending calibration and quality assurance checks. These are all standard aspects of space mission operations. However, here lies the discrepancy. NASA has not provided any explanation for this data gap. There is no official statement indicating that Psyche underwent a planned instrument reset during this time frame, nor any acknowledgement of a telemetry issue that has delayed the processing of early September data. There is simply an absence of information regarding this period of silence. I have attempted to obtain clarification through available channels. I have reviewed mission status updates. I have meticulously examined NASA's public communications. None of these resources address this specific gap. It is as if all parties involved with the Psyche mission, independently and concurrently, determined that the first week of September was not worthy of documentation, or alternatively that documenting it was too sensitive for public dissemination. Consider the implications. If this gap is indeed unintentional, a mere unfortunate confluence of routine maintenance coinciding with Atlas's closest approach, then transparency would be expected. One would anticipate NASA to state, yes, we were offline during that period. Here are the reasons. Regrettably, we missed observing Atlas, but here are our alternative actions. The lack of any explanation suggests either a level of negligence so profound as to approach incompetence, or a deliberate suppression of data that might have revealed something NASA is not yet prepared to disclose. Let us examine the timing with greater scrutiny. Atlas unexpectedly initiated its hydrogen cyanide emissions on September 14th, a mere 10 days after this mysterious period of silence. During the blackout window, Atlas would have been sufficiently close for detailed spacecraft imaging. Following the cessation of the blackout, Atlas was further away and undergoing its chemical transformation. It is almost as if the intention was to ensure that no high-resolution images existed from this critical transitional period. The days when Atlas might have been undergoing changes, activating, or exhibiting external indicators of its impending gas release. If Atlas is indeed artificial, possessing visible structural components, ports, or mechanisms that would betray its nature, such features might only be discernible through close-up observation utilizing spacecraft-grade instrumentation. Ground-based telescopes, even the most powerful among them, perceive Atlas as little more than an indistinct point of light. Psyche possessed the capability to alter this perception. Yet, during the exact period when this alteration could have occurred, Psyche went dark. Allow me to present a hypothetical scenario. Suppose Atlas began exhibiting structural anomalies in late August or early September. Suppose Psyche's imagery captured something significant. Panels opening, gas jets expelling from specific points rather than uniformly across its surface, geometric configurations inconsistent with natural fragmentation. Suppose those images were immediately flagged by automated analysis or by mission scientists who recognize the extraordinary nature of their observations. What would transpire next? Would NASA immediately release those images to the public? Or would they be classified, subjected to security reviews, and shared with defense and intelligence agencies before any public announcement? I am not asserting that this is definitively what occurred. I am suggesting that the archive's data gap is consistent with such an event, and the absolute silence from NASA regarding the reasons for this gap does little to inspire confidence in an innocent explanation. We will observe this pattern recurring throughout our investigation. Data gaps, delayed releases, low-resolution imagery when high-resolution alternatives should be available, spectral analyses requiring months when they should take mere weeks. This represents a subtle method of information management, not an overt falsehood, but a strategic control of data flow, ensuring the public receives only that which authorities deem them ready to know. On their timetable, within their framework, and while we are kept in ignorance, Atlas continues its inward journey, its cloud of hydrogen cyanide expanding. And whatever its purpose, whatever its evolution, we are being systematically prevented from observing it clearly. But Psyche's blackout is merely the prelude. Next, we must address the matter of Atlas's tail, or more precisely, the perplexing absence of its tail, and the baffling instances where it appears to point in directions that contradict our understanding of cometary behaviour. Part 3. The vanishing tail mystery. Comets are generally considered straightforward celestial objects. While the underlying physics can be complex, the fundamental concept is simple. A comet consists of a nucleus, essentially a dirty snowball of ice and rock. As it approaches the Sun, solar radiation heats its surface, causing the ices to sublimate, transforming directly from a solid to a gaseous state. This outgassing releases dust particles from the nucleus, forming a luminous envelope known as the coma. Subsequently, the solar wind, a stream of charged particles emanating from the Sun at tremendous speeds, propels the gas and dust away from the nucleus. Solar radiation pressure also contributes to pushing the dust particles. The predictable outcome is a tail that invariably points away from the Sun, irrespective of the comet's direction of travel. This orientation is dictated by the Sun's influence, not the comet's trajectory. This is a fundamental principle of cometary physics, understood since the 17th century. Therefore, when a comet's tail is observed pointing towards the Sun, it signals an unusual occurrence. The Hubble Space Telescope captured images of 3 Atlas in August of 2025, which should have depicted a typical coma and tail structure. Instead, astronomers noted a perplexing anomaly. Atlas displayed what is termed an anti-tail, a narrow feature extending in the direction of the Sun rather than away from it. While anti-tails are not entirely unprecedented, they can manifest when a comet is observed from a specific geometric vantage point. In such instances, we may perceive a view of dust particles that have accumulated within the comet's orbital plane, creating an optical illusion where a portion of the tail appears to align with the Sun. This is a projection effect, a distortion of perspective. However, these anti-tails are typically faint, slender, and readily explainable once the geometry of the observation is understood. Atlas's anti-tail did not conform to this standard profile. It was too prominent, too persistent, and the geometric alignment of Earth's observation point did not fully account for its presence. Amateur astronomers tracking Atlas reported even more peculiar observations. Instead of a smooth, continuous tail, they observed faint, intermittent bursts of gas, erratic jet-like emissions originating from the nucleus, and a coma that fluctuated in brightness unpredictably. On some nights, Atlas appeared active with a faint tail extending behind it. On other nights, despite being at the same distance from the Sun, it seemed almost inert, presenting as a mere point of light with minimal coma. This variability is highly unusual. Once a comet begins to actively outgaze, it generally maintains a baseline level of activity that correlates with solar heating. One would not expect it to flicker on and off like a malfunctioning light bulb, unless there were significant abnormalities in its nucleus, its rotation, or its internal structure. Compare this behavior to any typical comet you choose to consider. Take Comet Swan, officially designated C2025, which became visible earlier in 2025. Comet Swan was a spectacular celestial event. Ground-based telescopes captured it exhibiting a vast, brilliant coma and a textbook tail streaming away from the Sun. Amateur astrophotographers shared images revealing intricate patterns within the coma, concentric shells of gas and dust pulsing outward as the nucleus rotated, exposing fresh ice to solar illumination. Comet Swan behaved precisely as cometary physics predicts: bright, active, consistent, and visually stunning. Atlas, in stark contrast, is dim, unpredictable, and defies simple classification. If you were to place images of the two side by side, you would not readily assume they belong to the same category of celestial object. One resembles a comet, the other appears as an entity attempting to mimic a comet, but failing to execute the performance convincingly. So, what accounts for Atlas's anomalous tail behavior? Let us first examine the conventional explanations. Fragmentation is one possibility. If Atlas's nucleus is disintegrating, with fragments of ice separating from the main body, this could result in irregular outgassing as different fragments warm at varying rates. Fragmentation events often produce clouds of dust and jets that can temporarily intensify a comet's brightness before it fades. However, fragmentation typically leaves discernible evidence, such as multiple nuclei, expanding debris fields, and dramatic increases in brightness, followed by subsequent dimming. Atlas has not exhibited clear indications of breaking apart. Another potential explanation relates to the comet's rotation. If Atlas spins with its active vents concentrated in specific regions of its surface, we would observe variations in brightness as these vents rotate into and out of solar illumination. This could account for the flickering behavior, but it does not adequately explain the anti-tail. Rotation-induced jets would still be propelled away from the Sun by the solar wind and radiation pressure. They might produce asymmetric tails, curved tails, or even spiral patterns, but not a tail-oriented sunward. The interaction of charged dust particles with the Sun's magnetic field presents another possible mechanism. If Atlas is generating dust particles with unusual electrical charges, electromagnetic forces might propel some of this material in unexpected directions, temporarily overriding the radiation pressure. This is an unconventional but not impossible scenario. Comets are known to be electrically active environments. The solar wind is a plasma, composed of ionized particles carrying electric currents. Magnetic fields in space twist and reconnect. In such a dynamic environment, unusual phenomena can occur. However, even this explanation necessitates that Atlas possesses unusual chemical properties, producing dust or gas with characteristics distinct from those of typical comets. This brings us back to the fundamental question: why is Atlas so different? Here, our inquiry begins to venture into speculative territory, yet this speculation is firmly rooted in the anomalies we're observing. What if Atlas's tail is not entirely a natural phenomenon? What if directed emissions are involved? Imagine vents or nozzles releasing gas at specific angles, generating thrust that alters the comet's normal tail configuration. Picture a spacecraft firing its attitude control thrusters. The exhaust does not simply stream away based on solar wind pressure. It is directed wherever the thruster is aimed. If Atlas possesses any form of propulsion, even rudimentary gas jets for orientation or trajectory adjustments, those emissions would create visible plumes that would deviate from standard cometary tail behaviour. They could account for the erratic bursts, the intermittent brightening, and the anti-tail structures that are perplexing astronomers. I am not asserting that this is definitively the case. I am proposing it as a hypothesis that better aligns with the observed data than any conventional explanation I have encountered. And here lies an uncomfortable truth. If Atlas is artificial, if it is actively manoeuvring, if it is intentionally controlling its gas emissions for reasons we do not comprehend, then we are not dealing with a passive object that we can safely observe and disregard. We are confronting an entity possessing agency, something that may be responding to its environment, something that initiated the release of its hydrogen cyanide cloud at a precise time and location of its own choosing. This fundamentally alters our understanding of the situation. It transforms Atlas from a mere curiosity into a potential concern. To fully grasp the gravity of this threat, we must examine the very institutions tasked with its investigation and question their current obstructionism. This leads us to the European Space Agency and their remarkably odd handling of data pertaining to the Mars flyby. Part 4 introduces ESS Lockbox, detailing their game of delayed revelations. In early October of the year 2025, the celestial body designated 30-Cent Atlas completed a close passage of Mars, coming within approximately 5 million miles of the red planet. This presented a prime opportunity for scientific observation. The European Space Agency maintains 2 advanced spacecraft in orbit around Mars, the ExoMars Trace Gas Orbiter and Mars Express. Both are outfitted with sophisticated instruments designed to analyze atmospheric gases and capture imagery of distant celestial objects. As Atlas neared, the ESA publicly declared their intention to conduct observations, aiming to capture images and spectroscopic readings to ascertain the comet's composition and activity. This was standard scientific procedure. Atlas would be closer to these orbiting spacecraft than to any terrestrial telescope, potentially yielding unparalleled insights unattainable from Earth. The ESA maneuvered their spacecraft, oriented their instruments, and collected the requisite data, then commenced a period of waiting. On the 7th of October 2025, the ESA released preliminary images showcasing Atlas as a mere pinpoint of light against the starfield, captured by the Trace Gas Orbiter from a distance of roughly 30 million kilometers. These images were hailed as a significant technical achievement. The narrative was presented as a triumph. Look, we observed the interstellar visitor from Martian orbit. This is proof our instruments function effectively, and that international collaboration in space science yields tangible results. The accompanying press releases expressed considerable enthusiasm, but were conspicuously vague regarding specific details. The photographs indicated Atlas's location, its trajectory across the sky, and a faint gaseous halo. However, the resolution was poor, the images grainy, almost rudimentary in their lack of fine detail. Some observers quipped that they resembled graphics from early video games, appearing as pixelated smudges against a dark backdrop. Given the agency's consistent track record of producing striking, high-resolution images of Mars's surface, its atmospheric phenomena, and its moons, these Atlas images struck many as curiously unsophisticated. More crucially, the ESA announced that spectroscopic data, the measurements of gases emitted by Atlas, the identification of constituent molecules, and the determination of isotopic ratios, all vital information for understanding Atlas's origin and nature, would require several months of analysis before its public dissemination. Months. For spectroscopic analysis, the process is generally straightforward. One directs a spectrometer toward an object, gathers photons, analyzes their wavelengths, and identifies absorption or emission lines corresponding to known molecules. This is not an area demanding years of complex modelling. It is a routine aspect of observational astronomy. Even accounting for necessary calibration and an abundance of caution, a period of weeks should ordinarily suffice, not months. The question arises, what justifies this protracted delay? Let us contemplate the potential revelations contained within that spectroscopic data. We are already aware that Atlas is expelling hydrogen cyanide at extraordinary rates. But what other substances are being released? Might there be novel molecules, compounds that deviate from expected profiles? Could the isotopic ratios be anomalous, hinting at material formed under conditions distinct from those within our solar system or from what is anticipated in interstellar space? Is there any indication of synthetic compounds, molecules not found in nature? These are precisely the questions that spectroscopy is designed to answer, and these are the questions the ESA seemingly prefers to answer with deliberate slowness. By withholding the data, they maintain control over the narrative. They ensure that when the information is eventually disclosed, it will have been thoroughly examined, contextualized, and framed in a manner designed to mitigate alarm and emphasize scientific prudence. While these circumstances do not definitively prove a cover-up, they are entirely consistent with the behavior of institutional gatekeeping. Consider the ESA's reaction to Atlas, in contrast with their handling of other recent scientific findings. When Mars Express detected methane plumes within the Martian atmosphere, the data was released within weeks, igniting a robust scientific discussion regarding the potential origins, whether biological or geological. Similarly, when the Trace Gas Orbiter mapped water vapor concentrations in Mars's atmosphere, the findings were promptly published. Those discoveries, while significant, were not perceived as inherently threatening. They did not fundamentally challenge established assumptions about the possibilities within our solar system. Atlas, however, presents a different scenario. An actively emitting interstellar object in close proximity to Earth's orbital path, releasing hazardous gases, is an unprecedented phenomenon. Should that object exhibit signs of artificial origin or possess a composition inexplicable by natural processes, the ramifications would be profound. It is plausible that this very reality explains the ESA's deliberate pace, their gradual release of information, and their apparent strategy of observing public and scientific reactions before disclosing further details. Furthermore, the issue of interagency coordination warrants consideration. The ESA does not operate in isolation. They share data with NASA, with other international space agencies, and with elements of the defense and intelligence communities. If Atlas is indeed an extraordinary anomaly, and if spacecraft observations have indeed uncovered something remarkable, that information would invariably transcend the confines of the ESA's Science Directorate. It would be escalated, potentially classified, and discussed at levels far removed from public-facing researchers. The scientists engaged in data analysis might be instructed to proceed with extreme caution, to meticulously re-verify every detail, and to ensure that no premature conclusions are leaked. This would not necessarily stem from participation in a conspiracy, but rather from a natural institutional inclination toward caution when confronted with information that could potentially incite widespread panic or engender geopolitical instability. Let there be no doubt, confirmation of Atlas's artificial nature would be profoundly destabilizing. It would immediately necessitate answers to critical questions. Who constructed it? What is its purpose here? Does it pose a threat? Are there others? These questions would demand responses from governmental bodies, military organizations, and international consortiums entirely unprepared to address such complex issues. Consequently, the ESA is withholding the data. They are releasing aesthetically pleasing images that present no controversial information while assuring that detailed analysis is forthcoming. The message is simple. Patience is required. Science, after all, is a time-consuming endeavour. Meanwhile, Atlas continues its trajectory inward, drawing nearer to the Sun and to Earth, and those possessing access to the most critical data remain silent regarding their actual observations. However, we're not entirely without recourse. We can draw comparisons between Atlas and other celestial objects. we can leverage the existing observational data to construct a compelling argument. Among the most compelling pieces of evidence arises from posing a straightforward question. If Atlas were genuinely a typical comet, how would its observed behaviour compare to that of an actual comet, observed during the same time frame? The comparison is damning. However, before delving into that analysis, we must address an even more unsettling possibility. What if the cloud of hydrogen cyanide emanating from Atlas is not merely an emission, but rather a weapon? Part 5 explores the weaponized cyanide hypothesis. Let us discuss the concept of toxic clouds in space. It sounds like a plot ripped from the pages of science fiction, perhaps the narrative of a B-movie featuring malevolent extraterrestrials employing orbital gas attacks on Earth. However, the underlying physics are indeed real, and understanding them is crucial before dismissing the scenario as mere absurdity. Atlas is presently generating hydrogen cyanide at a rate of approximately 4 × 10 to the 10th molecules per second. While this is an almost incomprehensible quantity, let us contextualize it. If this output were to be collected for a single hour, the volume of hydrogen cyanide produced would be sufficient to fill several Olympic-sized swimming pools in gaseous form. Over periods of days, weeks, or months, the cumulative cloud would become immense. Yet space itself is also vast, and gases expand rapidly in a vacuum. By the time such a cloud reached Earth, its concentration would have diminished dramatically. The inverse square law is unforgiving. Doubling the distance reduces the concentration to 1/4, tripling it reduces it to 1/9. By the time any cloud originating from Atlas reached Earth, its diffusion would be so profound that detecting it would be exceedingly difficult, let alone experiencing any adverse toxic effects. Therefore, the hydrogen cyanide cloud emitted by Atlas, on its own, does not represent an immediate threat to life on Earth. Our atmosphere provides substantial protection. Even if a dense plume were to somehow reach our planet, it would likely combust in the upper atmosphere, dissociating into harmless atomic components, and would not reach the surface in dangerous concentrations. To achieve surface-level toxicity, one would require a deliberately targeted and sustained release directly into Earth's orbital path, coupled with an exceptionally improbable atmospheric entry trajectory. Such an event is not occurring naturally, but, and this is the pivotal question, could it happen intentionally? Could Atlas, assuming it is indeed an engineered object, manipulate its trajectory and emissions to deliver a concentrated toxic cloud to a specific target? This is where speculation enters, but it is not entirely beyond the realm of possibility. Envision Atlas possessing a propulsion system, perhaps a subtle one, utilizing its own outgassing as reaction mass. Minor trajectory adjustments, imperceptible from Earth due to our expectation that cometary orbits are solely governed by gravitational forces, could position Atlas such that its perihelion, its closest approach to the Sun, aligns directly with Earth's orbital path. Subsequently, at the opportune moment, it could release a concentrated burst of hydrogen cyanide, not dispersed indiscriminately in all directions, but directed through a specific nozzle or vent aimed at Earth's predicted position. The cloud would expand, but it would do so along a trajectory calculated to intersect Earth's orbit, precisely when Earth traverses that region. This represents a convergence of orbital mechanics and chemical warfare. Is it possible in principle? Yes. Is it practical? That depends entirely on Atlas's capabilities, which remain unknown to us. Let us consider the engineering prerequisites. Firstly, propulsion. Atlas would necessitate a mechanism for altering its velocity even by a small degree. Gas jets could serve this purpose. By expelling volatile material asymmetrically, thrust can be generated. This is analogous to how certain spacecraft manage their orientation, using small thrusters that vent gas. If Atlas possesses internal reservoirs and controllable venting systems, it could adjust its course. Secondly, targeting. Atlas would require knowledge of Earth's current and future positions, and the ability to calculate intercept trajectories. This implies the need for sensors, computational systems and ephemerides, capabilities well within the scope of any spacefaring civilization. Thirdly, timing. The release of hydrogen cyanide would need to occur at a precise moment when Atlas is positioned such that the expanding cloud intersects Earth's orbit at the correct time. Again, this is a matter of straightforward orbital mechanics, a problem entirely solvable. Now consider this disquieting possibility. The abrupt initiation of hydrogen cyanide emissions at a distance of 2.1 astronomical units may not be a random occurrence. It could represent a test, a system verification, confirming the functionality of internal mechanisms, the integrity of chemical pathways, and the condition of storage containers that may have remained sealed for centuries or millennia of interstellar travel. One might power up the probe, confirm emissions, monitor the cloud's expansion, observe ground-based reactions, and then proceed inward, gathering data, refining targeting, and awaiting the optimal release window closer to perihelion. This is precisely how one would engineer a reconnaissance and delivery system, incorporating redundancies, verification stages, and fail-safe mechanisms. The emission observed in September could well be such a pre-deployment test. If this hypothesis holds true, the implications are deeply unsettling. We would not be confronting a passive threat, an inert object that might coincidentally endanger us. Instead, we would be facing an active threat, an entity capable of responding to its environment, operating according to a programmed sequence, and possessing objectives that we can only surmise. The analogy of a muffler is worth contemplating. If Atlas houses a substantial internal engine, perhaps responsible for generating power for propulsion or communication, that engine would inevitably produce exhaust. Hydrogen cyanide could be a byproduct, a chemical signature revealing the nature of the technology operating within. Just as a car's exhaust indicates the combustion process, Atlas's emissions might illuminate its internal activity. And if that engine has only recently been activated, if systems have just come online, the sudden appearance of exhaust would align with our observations. This is not definitive proof, but it offers a framework that explains the observed phenomena more cohesively than natural cometry physics. The most dire potential timeline unfolds as follows. Atlas entered our solar system in a dormant state, a sleeper probe conserving energy, minimizing emissions, appearing as nothing more than an inert interstellar rock. As it approached the Sun, internal systems would monitor solar radiation, distance, and trajectory. Upon reaching a pre-programmed threshold, approximately 2.1 astronomical units, activation protocols would commence. Systems would power up, chemical reservoirs would open, and hydrogen cyanide would be vented, serving both as a test and as a byproduct of engine ignition. Ground-based observers would detect the emission, noting the anomaly, but mainstream science would interpret it as a natural cometry behavior. Meanwhile, Atlas would continue its inward journey, refining its trajectory and approaching perihelion at approximately 1.36 astronomical units. At this point, solar heating would be intense, natural cometry activity would peak, providing ideal cover for further emissions. Should Earth happen to be in the wrong place at the wrong time, a concentrated cloud could intersect our orbit, presenting a threat we would never have anticipated because we had mistakenly dismissed it as merely a comet. I wish to be unequivocal. This scenario rests upon assumptions. It presumes Atlas to be artificial, possessing capabilities we have not directly observed, and exhibiting intentions we can only infer. However, every alternative explanation, every attempt to categorize Atlas within the framework of normal cometry behavior leaves anomalies unexplained. The abrupt onset of emissions, the absence of a tail, the spacecraft communication blackouts, the delays in data release. At some juncture, the cumulative weight of these anomalies compels us to consider hypotheses we would rather avoid. And this hypothesis, the weaponized cyanide scenario, aligns distressingly well with the available data. However, there is a broader context to consider. a nexus of conspiracy theories and hidden agendas that suggest Atlas might be intrinsically linked to something even more extraordinary. To comprehend this, we must turn our attention to Project Blue Beam. Part 6 addresses the Blue Beam Trigger Protocol. There exists a conspiracy theory so intricate, so reminiscent of cinematic plots, that even seasoned skeptics find it compelling, if not entirely credible. It is known as Project Blue Beam. According to its proponents, it represents a clandestine operation orchestrated by shadowy global elites with the intention of fabricating an alien invasion. This alleged deception would be executed using advanced holographic technology, satellite-based projection systems, and electromagnetic manipulation. The purported objective is to instill widespread fear among the global population, compelling them to accept a unified world government, relinquish national sovereignty, and embrace authoritarian control in exchange for protection against a manufactured extraterrestrial threat. It is characterized as the ultimate false flag operation, a cosmic deception designed to exploit humanity's deepest fears for political gain. Most researchers dismiss Blue Beam as unfounded paranoia, a conflation of legitimate concerns about government propaganda with tropes from science fiction. However, within conspiracy circles, Blue Beam is regarded with seriousness, and there is a specific detection protocol that believers actively monitor. This protocol posits the following. Mainstream science and media have, for decades, actively debunked UFO sightings, ridiculed eyewitness accounts, and maintained that extraterrestrial visitation is highly improbable, bordering on impossible. If this prevailing narrative were to abruptly reverse, if prominent skeptics were to begin acknowledging the presence of alien life, if governments were to confess to tracking anomalous objects, this shift would signal the activation of Blue Beam. It would indicate that the stage is being meticulously set, that the public is being psychologically prepared, and that the holographic projectors are powering up. When the fabricated invasion commences, the public will accept it as genuine because their trusted authorities will have previously affirmed the reality of alien existence. This is described as predictive programming followed by execution, and once one is aware of this purported flip, it becomes difficult to ignore instances where it appears to be occurring. Over the past few years, we have observed precisely this shift. The United States government has declassified previously unreleased videos of UFOs. Pentagon officials have testified before Congress regarding unidentified aerial phenomena. Media outlets that once satirized UFO enthusiasts now present sober analyses of military encounters with unexplained craft. NASA has announced the establishment of dedicated UAP research programs. The cultural discourse surrounding aliens has transitioned from the fringe of conspiracy theory to the realm of serious inquiry. Staunch proponents of Blue Beam interpret this as confirmation. The trigger is being pulled. And now, rather conveniently, an interstellar object has appeared, exhibiting peculiar behavior, emitting toxic gases, and defying simple explanation. Could Atlas be the test balloon, the opening act, the preliminary event designed to condition the public for the subsequent phase? Let us explore this hypothesis with careful consideration. Assume, for the sake of argument, that Blue Beam is a genuine undertaking, or at least that influential entities seek to manipulate public perception regarding extraterrestrial threats. Atlas is ideally suited for such a purpose. It is a tangible object, detectable by both amateur astronomers and professional observatories. Faking its existence would be exceedingly difficult, given the numerous independent observers tracking it. However, the narrative surrounding it can be controlled. Information can be selectively released, anomalies can be emphasized while others are downplayed, and public concern can be gradually escalated. The initial narrative is, it's just a comet. Then, well, it's emitting unusual gases. Subsequently, its behavior deviates from our models. Finally, we're observing structures that do not appear natural. Each revelation incrementally heightens anxiety, preparing the audience for the next stage. Ultimately, when the full revelation is ready, whether it be a staged holographic invasion or an actual first contact scenario, the public will already be partially conditioned to accept it. They will have been persuaded to anticipate something extraordinary. The technology purportedly required for Blue Beam, while speculative, is not entirely beyond the realm of possibility. Satellite-based laser projection systems could generate atmospheric displays visible over vast areas, particularly at night. When combined with coordinated drone imagery, these could simulate fleets of spacecraft. The manipulation of electromagnetic frequencies, targeting the human brain's susceptibility to specific wavelengths, could induce mass hallucinations or auditory phenomena. Coupling this with media control, ensuring news outlets broadcast the approved narrative, creates a recipe for manufactured reality. Whether this technology exists at the scale envisioned for Blue Beam is debatable, but elements of it undoubtedly exist. The critical question is whether any entity possesses the will and the resources to deploy it. This is where Atlas's role becomes disturbingly pertinent. If the objective is to stage an invasion, initiating with a small distant object is a logical approach. It is manageable and does not immediately trigger widespread panic. It allows authorities to control the pacing of events. One can observe public reactions to initial anomaly reports, gauge which narratives gain traction online, and adjust the strategy based on real-time feedback. Atlas effectively becomes a live test, a psychological operation masterfully integrated with astronomical observation. And because it is a verifiable phenomenon, detected by actual telescopes, skeptics cannot dismiss it as pure fabrication. They are compelled to engage with the data, to attempt to explain the anomalies, and to confront possibilities they would prefer to disregard. Meanwhile, the public observes, absorbs, and gradually shifts from disbelief to a cautious acceptance of the notion that something in space is not what it initially appeared to be. Critics of the Blue Beam theory often highlight logical inconsistencies. The staging of a global deception of such magnitude would necessitate an unprecedented level of coordination among governments, space agencies, military organizations, and media outlets across numerous countries with inherently conflicting interests. The likelihood of leaks and the emergence of whistleblowers would be immense. The operation, they argue, would inevitably collapse under its own complexity. These are indeed valid objections. However, consider an alternative perspective. What if Blue Beam is not a coordinated conspiracy, but rather an emergent strategy? What if multiple actors, each pursuing their own agendas independently, converge on the same tactic, utilizing the narrative of an alien threat to justify budgets, exert population control, or divert attention from other pressing crises? In such a scenario, a secret cabal is unnecessary. Structural incentives alone could drive everyone toward the same behavior, and in that context, Atlas need not be an integral part of a master plan. It's merely intended to be a beneficial, a convenient predicament that various agendas exploit concurrently. I'm uncertain if Project Blue Beam is a reality. I don't know if Atlas is implicated. However, I recognize the observable pattern. I'm aware the prevailing narrative is transforming, and I understand that when patterns materialize, when the improbable starts to feel inevitable, it's prudent to inquire about who stands to gain. But let's momentarily set aside the conspiratorial perspective and consider an alternative pattern. One that astronomers have quietly documented for years. One that suggests Atlas might not be an isolated phenomenon. One that poses a simple yet chilling question. What if the very stars are not what they appear to be? Part 7. The Enigma of Disappearing Celestial Bodies. Beatrice Villa-Hoyle may not be a universally recognized name, but her research could be among the most disquieting contributions to astronomy in the last decade. By examining historical photographic plates, those glass negatives captured by telescopes throughout the 20th century and preserved in observatories worldwide, Vero began a process of cross-referencing ancient sky surveys with contemporary digital observations. Her objective was straightforward: to identify objects that were present in vintage photographs but have since vanished. She christened her undertaking Vasco, an acronym for vanishing and appearing sources during a century of observations. What she uncovered should have generated considerable attention. In her comparison with the US NOBAR's data, she identified approximately 100 sources that appeared as stars or star-like entities in the 1950s, yet showed no corresponding presence in current surveys. They had simply ceased to exist. Now, before we rush to extraterrestrial explanations, let's explore the conventional hypotheses. Photographic plates are notoriously delicate. Their emulsions degrade. Cosmic ray impacts can produce spurious points of light. Developer chemicals can leave behind residual marks. Dust particles on the glass can mimic stars. Atmospheric disturbances during exposure can generate phantom images that were never truly there. All of these are valid concerns, and Varrell's team meticulously addressed them. They filtered out obvious discrepancies, cross-checked multiple plates from different observatories, and concentrated on instances where the vanished object was consistently visible across several exposures. The outcome was a subset of disappearances that could not be readily attributed to instrumental or chemical anomalies. These objects genuinely appeared to be present in the 1950s and are demonstrably absent today. So, what became of them? Mainstream astronomy proposes several naturalistic explanations. A star that underwent a supernova event could have briefly intensified to detectable levels before collapsing back into obscurity. Light refractions from nearby luminous stars might have created illusory sources. Extreme variations in stellar luminosity could render a star visible at one juncture and invisible at another. Photometric calibration errors could lead to misinterpretations of the brightness of background galaxies, causing them to appear star-like when they are actually too faint for modern surveys to catalogue at that particular magnitude. These explanations account for many, perhaps most, of the candidates for vanishing stars. However, Villay asserts that a small residual group remains, cases where none of the standard explanations fit comfortably, and that is precisely where things become compelling. Let us assume, for the sake of argument, that some of these vanished objects were not stars at all. Suppose they were artificial light emitters, beacons, or probes positioned within our solar system or in adjacent interstellar space, operational during the mid-20th century for reasons unknown to us, and then powered down or relocated. How would we differentiate them from stars? Photographic plates possess limited resolution and sensitivity. A point source is a point source. If a probe aimed to disguise itself as a star, maintaining a consistent luminosity and exhibiting negligible apparent movement relative to the background over human timescales, it could easily deceive observers for decades. Subsequently, upon completion of its mission or depletion of its power source, it would simply switch off. The star would then vanish. We would be left bewildered, devising astrophysical explanations for something that was never astrophysical in the first place. This connects to Atlas in a disconcerting manner. If Atlas is artificial, if it is a probe dispatched by some non-human intelligence, it is likely not the first or the only one. Civilizations capable of interstellar transit would not dispatch a solitary scout. They would deploy fleets, networks, redundant systems. Some probes might be passive observers, occupying stable orbits, watching and recording. Others might be active, approaching stars, analyzing atmospheres, investigating planets. Over centuries or millennia, their operational status would fluctuate. Some would fail, some would complete their missions and deactivate, some would relocate. For us to detect them would depend on chance and perseverance. We might glimpse one briefly, catalogue it as a comet or asteroid, then lose track as it manoeuvres or powers down. Or we might perceive it as a faint star-like object, never realising its artificial nature until it disappears. The ramifications are profound. If even a fraction of Villaroy's vanished stars are artificial constructs, then our solar system and its immediate surroundings are far more populated than we have previously supposed. We're not alone in the cosmic expanse. We reside in a neighbourhood, potentially a bustling one. and we have remained oblivious because our methods of observation are incapable of distinguishing between natural and artificial point sources. Atlas might be a component of that concealed population, one probe among many, distinguishable only because it became active at a juncture when our detection capabilities had advanced sufficiently to discern anomalies. And if that is the case, then the sudden emission of hydrogen cyanide from Atlas might not signify preparations for an assault on Earth. It could be a signal, a burst of communication directed at other probes, a coordinated protocol that we have inadvertently intercepted. Consider the implications. We are eavesdropping on a conversation we do not comprehend, involving participants we cannot see, utilizing a language we have not deciphered. Atlas emits hydrogen cyanide. We interpret it as a cloud of poison. But what if it is a message encoded within molecular emission patterns, readable by sensors on other probes scattered throughout the system? What if the anti-tail, the erratic jets, and the timing of the emissions collectively constitute a data packet, a burst transmission stating, "I have arrived, systems operational, proceeding to the next waypoint"? We would not recognize it as communication because we are searching for radio signals or laser pulses, not chemical plumes. However, an advanced civilization might employ chemistry, biology, or physics beyond our current mastery. They might embed data within unexpected channels, exploiting aspects of nature that we barely comprehend. The vanishing stars, the abrupt appearance of Atlas, and its peculiar behaviors all suggest a concealed stratum of reality operating just beyond our perceptual threshold. And if we are only now beginning to perceive it, it is because our technology has finally caught up to the subtle nature of what exists out there. But there is another control mechanism at play, one that prevents us from probing too deeply, one that restricts who can reach out into that darkness, and it is enshrined in law, enforced by governments, and rarely questioned by the public. Let us discuss who is permitted to converse with the stars. Part 8. Radio Silence Regulations. You are at liberty to listen to space as much as you desire. You can erect a radio telescope in your backyard, orient it towards the heavens, scan across various frequencies, and record any signals you detect. This is entirely legal. Governments actively encourage amateur radio astronomy. Universities provide open access to data from professional observatories. The universe is in a constant state of broadcast, with pulses ticking like cosmic metronomes, quasars blazing across vast distances, and the cosmic microwave background humming at 3 Kelvin. You can listen to all of it. However, if you wish to transmit, if you intend to send a message outward, that presents a different scenario. Suddenly, you find yourself navigating a labyrinth of regulations, licensing requirements, and unwritten protocols that effectively limit deep space transmissions to government-sanctioned entities. Why? If space is empty, if no one is listening, what difference does it make who transmits? The International Telecommunication Union oversees the global allocation of radio spectrum. They assign frequency bands for terrestrial communication, satellite operations, navigation systems, and radio astronomy. Certain bands are designated as protected, reserved exclusively for passive listening to ensure that natural signals are not obscured by human-generated noise. Transmitting within these bands is expressly forbidden. This is understandable. We do not want interference compromising scientific observations. However, the restrictions extend further. High-power transmissions, particularly those directed beyond Earth, often necessitate special permits. National regulations vary, but in numerous countries, broadcasting towards space falls under the purview of telecommunications law, military communications law, or both. The stated justification is spectrum management and the prevention of interference. The underlying rationale, however, is control. Consider the logic. If authorities genuinely believe that extraterrestrial intelligence does not exist, or is not actively listening, there would be no compelling reason to restrict transmissions. One can shout into the void indefinitely without causing any harm. But if there is a suspicion otherwise, if there exists even a remote probability that someone is monitoring from afar, then unregulated transmission becomes a potential risk. What if an amateur astronomer, utilizing a homemade transmitter, dispatches a message that elicits a response? What if that response is hostile or is misconstrued as hostile, thereby triggering an interstellar incident that governments are unprepared to manage? It is deemed preferable to maintain centralized control over transmissions, ensuring that any contact is handled through official channels, subject to military and diplomatic oversight. This is the pragmatic explanation. The more disquieting explanation is darker. Governments desire exclusive communication rights because they have either already established contact or anticipate doing so, and they wish to avoid any interference from civilian endeavours. There is historical precedent for radio silence protocols. During the Second World War, vessels maintained radio silence in contested waters to avoid revealing their positions to enemy submarines. The same principle applies in space. If hostile probes are present, actively listening, analysing, and triangulating the sources of intelligent transmissions, then every broadcast we emit becomes a beacon, a targeting marker. Silence is paramount for survival. Yet, we have not remained silent. Humanity has been broadcasting inadvertently for over a century. Radio, television, radar, all have leaked into space, announcing our presence. Any nearby intelligence possessing sensitive receivers is aware of our existence. Therefore, the argument for enforced silence falters unless its purpose is not to conceal our existence, but to control the content of intentional messages. Let us engage in speculation. Suppose governments detected anomalous signals decades ago, subtle patterns within radio noise that suggested an artificial origin. Suppose they responded discreetly, tentatively initiating a covert dialogue with whatever entity was out there. Suppose that dialogue continues, mediated by classified agencies, conducted on frequencies inaccessible to the public. In such a scenario, civilian deep space transmission would represent a threat, as it could disrupt delicate negotiations or divulge information that the public is not privy to. The regulations are not about spectrum management, they are about maintaining secrecy. And if Atlas is part of that hidden ecosystem, a probe sent by whomever we have been communicating with, then its sudden activation might correspond with a message we sent or received. A diplomatic exchange that escalated from mere communication to direct action. I conversed with an amateur radio operator who voiced his frustration regarding these restrictions. He had constructed a sophisticated antenna array capable of detecting faint signals from deep space. His ambition was to conduct his own SETI experiments, searching for discernible patterns, and if he discovered anything noteworthy, he desired to respond. However, upon researching the legal prerequisites for transmitting beyond Earth, he encountered significant obstacles. Licensing agencies demanded detailed technical specifications, insisted on justifications for the proposed transmission, and ultimately discouraged him from proceeding. The implicit message was clear: listening is permissible, but communicating is not. He interpreted this as evidence that authorities are disinclined to permit public engagement with potential extraterrestrial intelligence on an independent basis. And perhaps he is correct. Perhaps the silence protocols are not designed to shield us from extraterrestrials. Perhaps they are intended to safeguard the secret from us. Now, let us connect this to Atlas. If civilian transmission is restricted, if only authorized entities are permitted to broadcast into space, then any signals Atlas receives, any communication protocols it adheres to, must originate from governmental sources. We are not merely passive observers of Atlas's actions. We may be unwitting participants in an interaction orchestrated by agencies that are accountable to no public oversight. And if that interaction deteriorates, if Atlas interprets a signal as hostile or receives instructions that we do not comprehend, we will bear the repercussions without ever knowing what precipitated them. The radio silence regulation ensures our continued ignorance, and ignorance, when confronting existential threats, represents the most perilous position imaginable. However, ignorance may prove to be temporary. Atlas is approaching its perihelion, its closest proximity to the Sun, and it is at this juncture that events could escalate beyond anyone's control. Part 9. Solar sabotage at perihelion. Perihelion signifies the moment of maximum solar influence for Atlas. Current orbital projections place its closest approach at approximately 1.36 astronomical units from the Sun, anticipated to occur in late November of 2025. 1.36 AU translates to approximately 127 million miles. This distance remains safely outside Earth's orbit, yet it falls well within the region where solar radiation intensifies dramatically. For a conventional comet, perihelion triggers peak activity. Surface ices sublimate at an accelerated rate. Dust production surges. The coma expands to its maximum brightness. Tails extend for millions of miles. It is the comet's zenith, a brief celestial spectacle before it arcs back into the frigid expanse of the outer solar system. But if Atlas is not a typical comet, if it is an artificial construct possessing engineered systems, perihelion could represent something entirely different. It could be the activation window, the precise moment when internal mechanisms powered by solar energy attain operational capacity. The Sun is not merely a source of light. It is a fusion reactor broadcasting across the electromagnetic spectrum, from radio waves to gamma rays. It emits a solar wind, a supersonic stream of protons and electrons traveling at speeds of 1 million miles per hour. It generates magnetic fields that twist and snap, unleashing coronal mass ejections, colossal clouds of plasma that can disrupt satellites and power grids upon impact with Earth. Crucially, it provides energy. Solar panels function by converting photons into electrical energy. Any spacecraft operating within the inner solar system relies on solar power. It is abundant, dependable, and requires no fuel. If Atlas is equipped with solar panels or a comparable energy collection system, its power output escalates quadratically as it draws nearer to the Sun. At 1.36 AU, solar radiance is approximately half of that experienced at Earth's distance. This is still ample to charge batteries, activate dormant systems, and execute pre-programmed operations. Envision Atlas as having been designed for hibernation during its interstellar journey, conserving energy, minimizing emissions, and drifting inert for centuries. As it entered our solar system, passive sensors detected increasing solar radiation. At a predetermined threshold of 2.1 AU, preliminary systems engaged, venting hydrogen cyanide as a test or a byproduct. Now, as it approaches perihelion, primary systems prepare for activation. Whatever task Atlas was dispatched to perform, it will execute it when solar power reaches its peak. This could involve deploying secondary probes, transmitting data back to its origin, adjusting its trajectory for an encounter with a planet, or deploying something entirely unforeseen. And all of this would transpire concurrently with the period of heightened activity for a natural comet, thus providing perfect camouflage. Observers would anticipate Atlas to increase in brightness, emit more gas, and behave erratically. Any anomalies would be attributed to cometary physics rather than artificial intervention. There is another factor at play. Solar activity itself is inherently variable. The Sun operates on an approximately 11-year cycle, alternating between solar maximum, characterized by frequent sunspots, flares, and CMEs, and solar minimum, when activity subsides. We are currently approaching the next solar maximum, projected for around 2025 to 2026. This implies that Atlas's perihelion coincides with heightened solar activity, increasing the probability of flares and CMEs. If Atlas is engineered to harness or react to solar phenomena, this timing is exceptionally opportune. A well-timed CME could deliver a surge of charged particles, energizing its systems, triggering protocols, or even masking Atlas's own emissions within the natural solar storm. Ground-based observers would find it exceedingly difficult to differentiate artificial signals from solar noise, it presents an ideal cover. Let us consider a worst-case scenario. Atlas reaches perihelion in late November. A moderately sized CME is launched from the Sun, travelling outward. Atlas's trajectory positions it directly in the CME's path. The plasma cloud engulfs the probe, delivering an electromagnetic pulse and a flood of high-energy particles. Atlas's systems designed to activate under these conditions respond. Vents open. Stored volatiles are released directionally, generating thrust. The probe adjusts its trajectory, now aimed at a calculated intercept with Earth's orbit. Simultaneously, additional gas emissions, including concentrated hydrogen cyanide, are expelled along vectors designed to intersect Earth's position weeks or months later. From our vantage point, we would observe a comet naturally brightening at perihelion, perhaps exhibiting slight fragmentation and displaying robust cometary activity. We would remain unaware that the comet is maneuvering, targeting, and weaponizing its emissions until it is too late. Is this scenario plausible? Physically, yes. Orbital mechanics permit trajectory adjustments through directed thrust. Chemistry provides the propellant. Solar power furnishes the energy. The sole unanswered question is whether Atlas possesses the requisite engineering, and we are unable to answer that question because the data is either concealed, delayed, or dismissed. NASA's psyche went dark during the optimal observation window. A is withholding spectroscopic results. Hubble images reveal anomalies that are explained away as projection effects. The framework for this potential catastrophe is already established. The only element of uncertainty is intent. If Atlas is a probe, does it harbour hostile intentions, or is it merely indifferent, executing protocols that coincidentally pose a threat to us? Regardless of the intent, perihelion marks the critical juncture. After late November, Atlas's trajectory will be definitively set. If an event is imminent, it will commence then, and we will be watching, powerless, hoping that the anomalies resolve into something benign, yet simultaneously preparing for the possibility that they do not. But how do we even recognize the threat? How do we differentiate a comet from a weapon? The answer lies in comparison, and that is precisely what we are about to undertake. Part 10. Control Case. Swan versus Atlas. The Smoking Gun. Scientific progress is contingent upon comparison. One does not establish the unusual nature of something by studying it in isolation. Instead, one demonstrates it by contrasting it with the typical case, thereby showing that the observed deviations exceed expected variations. This is the rationale behind control groups in experimental research. This is why astronomers meticulously catalogue thousands of celestial objects, thereby building statistical baselines for what constitutes normal. And when something deviates significantly from this baseline, it warrants thorough investigation. Comet C 2025 R2, designated Comet Swan, provides the ideal control case for Atlas. Both are comets. Both exhibited activity during 2025. Both were observed using similar instruments, yet their behaviours could not be more divergent. Comet Swan appeared in the inner solar system in early 2025, discovered by the Solar and Heliospheric Observatory's wide-field images. It was a celestial wanderer, a fragment originating from a much larger comet that had fragmented centuries prior, now charting a course that would bring it within a few million miles of the Sun's incandescent surface. Astronomers had anticipated remarkable phenomena as Swan approached its closest point to the Sun, its perihelion, in March of 2022, and their expectations were certainly met. Swan blossomed into a colossal coma, a radiant envelope of gas and dust, discernible even through modest backyard telescopes. Its tail, extending across millions of miles, transformed into a luminous stream of ionized particles propelled by the solar wind, a spectacle captured by amateur astronomers across the globe. The European Space Agency's SOHO spacecraft meticulously documented Swan's final descent toward the Sun, observing its dramatic intensification in brightness, its partial vaporization, and its eventual fate as either a shattered remnant or a significantly diminished core, Swan embodied every characteristic one expects of a comet: brilliant, dynamic, predictable, and breathtakingly beautiful. Now, consider Atlas. Its discovery in the year 2024 revealed a distinct trajectory. Atlas entered our solar system not from the distant Oort cloud, as Swan had, but from interstellar space. Its orbital path was hyperbolic and unbound, signifying that following its perihelion, it would permanently depart the solar system unless its velocity underwent alteration. This characteristic alone renders Atlas noteworthy, though not entirely unprecedented. We have indeed witnessed other interstellar voyages, such as Oumuamua in 2017 and Boris in 2019. What sets Atlas apart is its peculiar behaviour. Throughout the majority of its approach, Atlas remained remarkably faint, barely discernible and exhibiting minimal cometary features. There was no bright coma, no discernible tail, merely a dim point of light that slowly increased in luminosity as it drew nearer to the Sun. Then, in mid-September of 2025, at a distance of 2.1 astronomical units, emissions of hydrogen cyanide abruptly surged. This was not water vapour or carbon monoxide, which are far more common volatile compounds in comets. Instead, it was hydrogen cyanide, a less abundant and more volatile substance, appearing with sudden intensity. Compare the imagery. Swan's coma presented as radiant and symmetrical, expanding uniformly as gas and dust were expelled from the nucleus. Atlas, conversely, displayed a faint asymmetric coma, marked by jet-like formations that suggested localized emissions rather than a uniform sublimation process. Swan's tail was a textbook example, streaming away from the Sun in an elegant arc, sculpted by radiation pressure and solar wind. Atlas's tail, however, proved erratic, appearing and disappearing unpredictably, and at times even pointing toward the Sun, seemingly defying fundamental physical principles. If you presented these images to a planetary scientist without any context, they would immediately identify Swan as a comet. Atlas, however, would undoubtedly provoke a cascade of questions. What is this object? Why is it behaving in this manner? Is there an error in the data? The contrast in brightness is equally striking. Swan achieved naked eye visibility, reaching a magnitude of 3 or 4 at its peak, easily observable from dark locations. Atlas, conversely, remained dim, a magnitude of 10 to 12, requiring the use of respectable amateur telescopes for detection. This disparity is significant because brightness directly correlates with activity. A bright comet is actively sublimating, releasing substantial quantities of gas and dust. A faint comet, by contrast, is largely dormant. Yet Atlas is expelling hydrogen cyanide at astonishing rates, approximately 4 times 10 to the power of 25 molecules per second. Where is the dust? Where is the reflected sunlight that should contribute to its brightness? This suggests either that Atlas's nucleus is exceptionally dark, absorbing light rather than reflecting it, or that its emissions are predominantly gaseous, lacking the dust component responsible for the glowing appearance of comets. Both of these possibilities are highly unusual. Herein lies the crux of the matter. If Atlas and Swan were both natural comets, products of the same physical processes, they ought to exhibit comparable behaviours, scaled according to their respective sizes and compositions. However, this is not the case. Swan's behaviour aligns perfectly with centuries of cometary scientific understanding. Atlas, on the other hand, behaves as an anomaly, an outlier, an entity that seems to operate under different physical laws. One could reasonably argue that Atlas is simply a peculiar comet, that natural variations within cometary behaviour are substantial, and that our understanding of cometary physics is incomplete, and such an argument would carry weight. However, when one considers the sudden surge of hydrogen cyanide, the apparent anti-tail, the instances of spacecraft communication blackouts, the delays in data transmission, and its sudden activation at a specific distance, the accumulation of these anomalies begins to shift the balance of probability. At a certain point, relying solely on the argument of natural variation becomes less plausible than exploring alternative explanations, and the alternative proposition that Atlas is an artificial construct, engineered and following a programmed sequence, offers a more elegant explanation for the observed data. We will revisit this comparison as Atlas approaches its perihelion in late November. Should Atlas suddenly brighten, develop a massive coma and tail, and exhibit behaviour akin to swans, then it is conceivable that the observed anomalies were merely early-stage peculiarities that resolved into typical cometary activity. However, if Atlas persists with its erratic behaviour, if the hydrogen cyanide emissions intensify without a corresponding increase in brightness, if the tail continues to be anomalous, or if new, unexplained features emerge, then the case for its artificial origin gains considerable strength. This is not the conclusion of our inquiry. Rather, it represents the midpoint. We are observing in real time as data accumulates, as Atlas gradually reveals its true nature, and as an answer becomes increasingly unavoidable. And while our attention is focused on Atlas, other developments in science and technology are quietly revolutionizing our perception of what is achievable. The world of 2025 is demonstrably more enigmatic than it was even 5 years ago. Let us broaden our perspective and examine other unfolding events, for context is paramount. The universe does not operate in isolation, and neither, it seems, does Atlas. Part 11. AI accurately forecasts the downfall of fusion startups. In October of 2025, a research consortium at MIT published a sobering analysis employing machine learning models to predict the long-term viability of private companies engaged in fusion energy research. Fusion, the very process that powers the stars, has been a long-sought aspiration for humanity for nearly a century. The successful attainment of controlled fusion on Earth would unlock a source of virtually limitless clean energy. Deuterium, a key fuel component, can be readily extracted from seawater. Its byproduct, helium, is non-reactive. The process offers the promise of zero carbon emissions and no risk of meltdowns, simply abundant and sustainable power. For many decades, controlled fusion remained a perpetually distant goal, often humorously referred to as being 30 years away in physics departments. However, during the decade of the 2000s and 20s, private enterprises began to seriously invest in this pursuit. Companies such as Commonwealth Fusion Systems, TAE Technologies, and Helium Energy, alongside dozens of other startups funded by billionaires and venture capital, all declared their intention to achieve commercial fusion by the 2000s and 30s. The MIT study cast a considerable shadow over this optimistic outlook, leveraging financial modelling, technical evaluations, and historical data pertaining to the deployment of energy technologies. The artificial intelligence predicted that approximately 70% of these enterprises would cease to operate by the year 2030, failing to overcome significant engineering hurdles or to secure adequate financial backing. Why is this relevant to Atlas? Because energy is intrinsically linked to power, both in a literal and a political sense. The control over energy resources dictates which nations hold sway, which economies flourish, and which populations experience prosperity versus hardship. If fusion technology proves successful, it has the potential to democratize energy production. Any nation possessing the requisite technical expertise could construct fusion reactors, thereby eliminating dependence on fossil fuels, uranium, and vulnerable geopolitical supply chains. Conversely, if fusion fails, if the startups collapse, and if this ambitious dream falters once more, then existing power structures will likely endure. Nations that are major oil producers would retain their global influence. Nuclear power, with its inherent challenges concerning waste disposal and proliferation, would remain a significant player. Renewable energy sources, despite their environmental benefits, would continue to necessitate massive infrastructural investment in grid systems due to their intermittent nature. The status quo, therefore, would persist, and within this established framework, an external anomaly such as Atlas could become a convenient diversion. Envision a scenario where governments feel compelled to justify immense budgetary allocations, to consolidate authority, and to rally their populaces behind a common external threat. The appearance of an extraterrestrial probe, a cosmic menace, or a weapon deliberately aimed at Earth would serve as the perfect catalyst for such a crisis. Consider the timing. Fusion companies are facing significant challenges in the year 2025. The AI models forecast that the majority will fail by 2030. Atlas emerges in 2024, becomes active in 2025, and is projected to reach perihelion in late 2025. If Atlas's activity escalates, if it is publicly perceived as a threat, governments might declare a global emergency. Resources would be diverted, civilian fusion projects could be nationalized or defunded, and military priorities would take precedence. Space defense initiatives would then serve as justification for defense budgets exceeding any seen previously. Concurrently, the private fusion sector, which held the potential to democratize energy, would likely collapse due to insufficient investment. While I am not asserting this is a deliberate coordinated plan, systems do not require explicit conspiracies to produce outcomes that appear conspiratorial. Incentives naturally align, and crises are often exploited. The AI's prediction regarding the failure of fusion startups may be accurate in its own right, but it also highlights a period of vulnerability, a time when humanity's energy future is uncertain, and fear might dictate policy more strongly than optimism. Let us introduce another dimension to this narrative. If Atlas is indeed artificial, a creation of an advanced civilization, what would such a civilization know about us? If they have been observing Earth for decades, or even centuries, they would undoubtedly comprehend our energy-related struggles. They would recognize our reliance on combustion technologies, our slow progress toward achieving fusion power, and the geopolitical tensions that arise from energy scarcity. An intelligence seeking to destabilize or manipulate humanity might strategically choose a moment of maximum impact for their intervention, arriving when we are least prepared, when our technological optimism is waning, and when our internal divisions are most pronounced. The arrival of Atlas in the mid-2000s, coinciding with this period of fusion uncertainty, escalating global tensions and mounting climate and economic pressures, appears either as an extraordinary coincidence or as a calculated act of timing. And I must confess, I am increasingly disinclined to believe in coincidences. This discourse is not solely about Atlas. It is about recognizing that existential threats do not materialize in a vacuum. They intersect with pre-existing crises, amplify them, and exploit inherent vulnerabilities. Regardless of whether Atlas is a probe, a weapon, or a natural celestial body, our current understanding is likely flawed. Its ultimate impact on human civilization will be contingent on the broader context, and that context in the year 2025 includes an energy sector teetering on the brink, pervasive geopolitical instability, and a populace increasingly skeptical of established institutions. Atlas could very well serve as the spark that ignites a conflagration within a highly flammable situation. However, energy is not the only frontier where peculiar events are unfolding. Let us shift our focus outward, towards the vast dark expanses between the stars, where unseen entities silently drift, awaiting discovery. Part 12. The Milky Way's rogue black hole update. Black holes represent the ultimate predators of the cosmos. Their gravitational pull is so immense that not even light, the fastest entity known, can escape their clutches. Space-time itself becomes warped into a one-way trap, a domain where the conventional laws of causality break down at the event horizon. Most black holes that we're aware of fall into two primary categories: stellar mass remnants, typically ranging from 10 to 100 times the mass of our Sun, formed when massive stars collapse in spectacular supernova explosions, or supermassive entities possessing masses of millions to billions of suns, residing at the centers of galaxies like cosmic engines of destruction. Both of these types are detectable because they interact violently with their surrounding environments. Stellar mass black holes often exist within binary star systems, where their intense gravity pulls gas from companion stars, heating it to millions of degrees through friction and compression. This superheated gas then glows brilliantly in X-rays, making the black hole's presence detectable. Supermassive black holes, on the other hand, power quasars, consuming material equivalent to entire solar systems within their accretion disks, broadcasting immense amounts of energy across the electromagnetic spectrum with luminosities that can outshine entire galaxies. But what about isolated black holes? These are black holes that drift alone through interstellar space, not actively feeding, not emitting light, remaining invisible except for their gravitational influence. How many of these exist? The answer is, we do not know. We are fundamentally incapable of observing them directly. They emit no radiation, reflect no light, and appear as absolute voids against the cosmic backdrop. Our only means of detecting them is when they happen to pass in front of a more distant star, briefly magnifying its light through a phenomenon known as gravitational microlensing. This effect, predicted by Einstein, occurs when massive objects bend space-time itself, acting as a natural lens that focuses and brightens the light from background sources. The effect is subtle, temporary, and requires an extraordinary degree of luck to observe. In September of 2025, a research team analysing data from the Hubble Space Telescope and various ground-based observatories announced the detection of a rogue black hole, estimated to be approximately 12 solar masses, drifting through the Milky Way at a distance of roughly 4,000 light-years from Earth. This detection stemmed from a microlensing event that persisted for several months, during which the light from a distant star intensified and then diminished in a pattern consistent with a massive dark object traversing the space between us and that star. By meticulously analysing the light curve, the precise pattern of brightening and dimming over time, the duration of the event and the magnitude of the brightening, astronomers were able to calculate the mass and velocity of the lensing object, 12 solar masses, moving at approximately 100,000 miles per hour relative to the surrounding stellar population. This object is indeed a rogue, a black hole that was ejected from its birthplace, possibly during an asymmetric supernova event that imparted a significant gravitational kick. It is now wandering the galaxy, invisible, detectable only by a fortunate alignment of geometric circumstances. The mathematical analysis required to confirm this object's identity was formidable. The researchers had to meticulously distinguish the black hole's signature from numerous other potential variables, including stellar variability, instrumental noise, and atmospheric distortion. They cross-referenced observations from multiple telescopes, validated the event through independent datasets, and modelled various scenarios to eliminate alternative explanations. A planet, for instance, would not produce the observed light curve. A dim star would exhibit different chromatic effects. Only a black hole was found to be consistent with all the observed data. This remarkable achievement represents years of painstaking effort, involving automated surveys that continuously monitor millions of stars simultaneously, patiently awaiting the telltale signature of gravitational lensing to emerge. The discovery raises a disquieting question. If we have managed to identify just one rogue black hole through microlensing, how many more exist undetected? Microlensing events require an exceptionally precise alignment. The black hole, the background star, and Earth must all fall within a minuscule angular tolerance, typically less than a millisecond of arc, an angle far smaller than the angular size of a dime viewed from 1,000 miles away. The probability of any given star being lensed at any particular moment is exceedingly small. Therefore, the detection of even a single rogue black hole strongly implies the existence of a much larger population. Some estimations suggest that tens of millions of stellar mass black holes are currently drifting through the Milky Way, with the majority concentrated in the galactic disk where star formation is most active, while others are scattered throughout the galactic halo. All of these remain invisible unless they happen to lens a star or encounter matter to accrete. We are, in essence, swimming in a sea of invisible gravitational traps, and we only become aware of them when we accidentally stumble into their detection cones. Consider the implications. Our galaxy is approximately 100,000 light-years in diameter, containing hundreds of billions of stars. If tens of millions of black holes are dispersed throughout this vast volume, the average distance between them could be a mere few dozen light-years. This proximity means that stellar mass black holes could pose a significant hazard to any future interstellar journeys. A spacecraft travelling between stars would need to meticulously map these invisible obstacles, devise methods for their detection, and meticulously navigate around them. And if we're only just beginning to discover them through microlensing, how would an advanced interstellar civilization approach this challenge? They would require detection capabilities far exceeding our current understanding. Perhaps gravitational wave sensors sensitive enough to detect the subtle distortions in space-time caused by isolated black holes, or access to exotic physics that we have yet to discover. Now, let us connect this back to Atlas. We operate under the assumption that we possess a comprehensive understanding of the objects within our solar system. Through decades of systematic surveys, we have catalogued asteroids, comets, and Kuiper Belt objects. We diligently track near-Earth objects that may pose a collision risk, maintaining extensive databases of potentially hazardous asteroids. We believe we have a reasonably accurate census of these objects. However, if the Milky Way is populated with numerous invisible black holes that we are only now beginning to detect, what else might we be overlooking? Dark, non-emitting entities that do not conform to our established detection paradigms, probes that meticulously minimize their electromagnetic signatures, or artificial structures that effectively blend in with natural celestial debris. The discovery of the rogue black hole serves as a potent reminder that the absence of evidence does not equate to evidence of absence. Simply because we have not yet observed something does not mean it does not exist. It may simply be rendered invisible by our current observational methods, residing within blind spots that we have not yet even recognized. Now, I am not suggesting that Atlas is a black hole. It is clearly emitting light and gas, detectable by telescopes operating across multiple wavelengths. However, the underlying principle remains valid. Atlas appeared suddenly within our detection systems, initially classified as a comet, because that is precisely what our survey telescopes are optimized to identify. Had it remained dormant, had it not activated its hydrogen cyanide emissions when it did, it might have traversed the inner solar system entirely unnoticed, perceived merely as another faint asteroid on a hyperbolic trajectory, too small and too dark to trigger our automated detection algorithms. The fact that we are tracking it now is almost fortuitous, contingent upon its becoming active at a time and in a location where our instruments were capable of detecting that activity. How many other Atlas-like objects have transited the inner solar system undetected throughout human history? How many are currently present, dormant and waiting, invisible until they choose to reveal themselves, or until we develop detection methods sufficiently sensitive to locate them? The rogue black hole also serves as a stark illustration of cosmic indifference. That 12 solar mass black hole harbours no animosity towards Earth. It is not targeting us. It is simply drifting, obeying the fundamental laws of orbital mechanics, a passive consequence of astrophysical processes that have been in motion for billions of years. If its trajectory were to intersect Earth's orbit at the precise moment we occupy that point in space, our destruction would be inevitable. This would not be the result of malice or deliberate targeting, but simply a matter of sheer, random cosmic misfortune, a chance alignment. Atlas might be analogous. It may not be a weapon intentionally aimed at humanity. It could be a probe following a pre-programmed route, executing survey protocols devised millennia ago, and we, by chance, find ourselves in its path. Intent becomes irrelevant if the outcome is catastrophic. A bullet does not need to harbour hatred to be lethal. Recognizing that the universe does not revolve around humanity, that celestial objects and entities pursue their own agendas with utter indifference to our survival, is both a humbling and a terrifying realization. It compels us to confront our own cosmic insignificance. We are not the central focus of creation, nor the pinnacle of cosmic evolution. We are merely one species on one planet, potentially situated directly in the path of forces and entities that we barely comprehend. This understanding should fundamentally shape how we approach the question of Atlas, how we consider the possibility of extraterrestrial contact, and how we define our place within the vast expanse of the cosmos. And this theme resonates powerfully with other recent discoveries, particularly within the realm of physics, where we are encountering evidence that reality itself may operate on principles that are currently beyond our comprehension, where quantum mechanics and relativity offer tantalizing hints of deeper structures that we are only beginning to glimpse. Part 13. Quantum time crystals achieve first practical demonstration. Quantum mechanics is, to put it mildly, peculiar. This is not an exaggeration. It is a statement of accurate description. Particles exist in a state of superposition, simultaneously occupying multiple states until they are observed. Entangled particles exhibit instantaneous correlations across vast distances, defying conventional intuitions about locality. The uncertainty principle imposes fundamental limits on the precision with which we can know certain properties. And now, in the year 2025, physicists have successfully demonstrated the existence of stable time crystals, a phase of matter so extraordinarily strange that even seasoned quantum theorists initially struggled to accept their potential existence. A time crystal is defined as a system that exhibits periodic behavior in the temporal dimension, not merely in space. Conventional crystals, such as salt or diamond, possess atoms arranged in repeating spatial patterns. If you disturb such a crystal, it will eventually return to its equilibrium state. In contrast, a time crystal oscillates perpetually, cycling through different states without any external input of energy, never truly settling into a state of equilibrium. Its motion occurs without any net energy cost, representing a form of temporal order that initially appears to violate the laws of thermodynamics. However, it does not technically do so, as time crystals exist within carefully engineered non-equilibrium systems that exploit specific quantum effects. The concept, upon first hearing, sounds utterly impossible. After all, perpetual motion machines have been dismissed as pure fantasy for centuries, definitively prohibited by the fundamental laws of thermodynamics. Energy cannot be conjured from nothing. The fundamental principle of physics dictates that entropy invariably escalates within isolated environments. Nevertheless, time crystals manage to circumvent these constraints by manifesting in open quantum systems. Within these systems, a continuous influx of energy sustains them in a peculiar state, not one of equilibrium, but rather a stable, enduring oscillation that persists indefinitely. Envision it as a quantum analogue to a celestial body in orbit around a star. Once set in motion, this orbital path continues without requiring additional energy input, yet it doesn't generate energy from nothing. The system is initialized with specific conditions that facilitate this perpetual cyclic motion. In March of 2025, a team at Google's Quantum Artificial Intelligence Laboratory announced the successful creation of a time crystal within their Sycamore quantum processor. This crystal maintained its coherence for more than 100 oscillation cycles, a duration significantly longer, by orders of magnitude, than any prior attempts. Achieving this feat necessitated an exceptionally precise control over quantum states, involving the manipulation of individual qubits with laser pulses timed to the femtosecond. The researchers demonstrated that the system oscillated at precisely half the driving frequency, a definitive characteristic of time crystalline behavior. Crucially, they showed that this oscillation remained stable, even when subjected to disruptions intentionally introduced to destabilize it. The time crystal proved remarkably resilient, possessing a self-correcting nature that preserved its temporal pattern through conditions that would typically degrade conventional quantum states. In August of 2025, scientists at the Massachusetts Institute of Technology showcased a room temperature time crystal, constructed using a lattice of nitrogen vacancy centers within a diamond. This type of system holds the potential for scalability for practical applications. This groundbreaking development obviated the need for temperatures near absolute zero and specialized superconducting hardware, thereby transitioning time crystals from highly controlled laboratory settings to environments where real-world applications become a tangible possibility. The methodology involving diamond lattices leverages imperfections within the crystalline structure, specifically locations where nitrogen atoms substitute for carbon atoms, thereby generating quantum systems that can maintain coherence at ambient temperatures. These nitrogen vacancy centers can be precisely manipulated with microwaves and lasers, coaxing them into time crystalline states that exhibit remarkably stable oscillations. These phenomena are far more than mere curiosities destined for academic journals. Time crystals possess the potential to revolutionize quantum computing by providing stable qubits that resist decoherence, a primary obstacle hindering the scalability of quantum computers to practical levels. They could pave the way for ultra-precise sensors, clocks of unparalleled accuracy that never deviate beyond quantum limits, and memory storage that remains perpetually unfaded as information is encoded in temporal patterns rather than spatial configurations. Speculatively, they might even underpin technologies we have yet to conceive, enabling the exploitation of temporal structures in ways that are fundamentally prohibited by classical physics. Some theoretical investigations suggest that time crystals could be employed in quantum communication protocols for the detection of gravitational waves with extraordinary sensitivity, or even for probing the very essence of time itself. If human scientists in 2025 are demonstrating time crystals, what might an advanced extraterrestrial civilization have achieved centuries or millennia ago? If Atlas is an artificial construct, its internal mechanisms might operate on principles of physics that currently elude our comprehension. Time crystalline cores could provide stable energy reserves, maintain coherent quantum states for computational or communication purposes, or facilitate mechanisms for subtly manipulating space-time. We would not be able to discern these technologies by merely observing Atlas from the exterior. A thorough examination, involving dismantling the probe and analyzing its materials at an atomic resolution, would be necessary to comprehend its operational principles. However, from a distance we would perceive only anomalies, behaviors that deviate from natural models, emissions that lack correlation with expected thermal or chemical processes, and trajectories that suggest a level of precision surpassing natural gravitational dynamics. Consider the observed emission of hydrogen cyanide. We interpret this as a consequence of sublimation, where ice heats up and transforms into vapor as Atlas draws nearer to the Sun. But what if this emission is merely a byproduct of a time crystalline energy system? What if Atlas employs a quantum process that generates waste products, and hydrogen cyanide happens to be one of them? The observed emission pattern, its sudden commencement and sustained production, would then reflect the system's activation rather than solar heating. This hypothesis would account for why the emission did not correlate predictably with Atlas's distance from the Sun, and why it appeared abruptly rather than gradually intensifying, as thermal models would predict. It was not thermally driven, it was technologically driven, and if time crystal technology is involved, the system could operate with exceptional efficiency, minimal energy dissipation, and sustained functionality over timescales that render conventional power sources antiquated by comparison. The energy budget alone is highly indicative. Chemical reactions store energy in molecular bonds, which is then released through combustion or electrochemistry. Nuclear reactions tap into the binding energies of atomic nuclei. Both these processes are unidirectional. Once the fuel is depleted, it is gone. Time crystals, in contrast, maintain their oscillations indefinitely once initiated, requiring only a minimal energy input to preserve coherence against ambient environmental noise. For a probe traversing interstellar distances, this distinction could represent the difference between an operational lifespan measured in decades and one measured in millions of years. A time crystalline power system would not by itself provide propulsion. Propellant would still be necessary for that. However, it could power computational systems, sensors, communication arrays, and control mechanisms essentially in perpetuity. Atlas might have been launched when humans were still inhabiting caves and could remain fully functional even today. It is important to emphasize that this is speculative. We currently lack any definitive evidence that Atlas incorporates time crystals or any other form of exotic quantum technology. However, the successful laboratory demonstrations of time crystals in 2025 have broadened the spectrum of plausibility, compelling us to re-evaluate what is technologically achievable. Merely 5 years prior, time crystals were confined to theoretical discussions, abstract mathematical constructs that physicists debated might even contravene fundamental physical laws. Today, their laboratory realization, with practical applications on the horizon, marks a significant advancement. When one extrapolates this rate of progress across centuries and considers a civilization possessing resources and knowledge far exceeding our own, the technological disparity becomes immense. Atlas could be to our spacecraft what our smartphones are to rudimentary stone tools. We can recognize that it is performing some function, and we can measure certain outputs, but comprehending its internal workings and grasping its underlying principles might lie entirely beyond our current conceptual framework. There is an additional implication worth considering. Time crystals challenge our prevailing understanding of entropy, the unidirectional flow of time, and the tendency of systems to evolve towards disorder. They suggest that under specific circumstances, behaviors akin to perpetual motion are achievable within the confines of quantum mechanics. If a civilization were to master this principle, they could construct machines capable of operating indefinitely without the need for refueling. Such machines could include probes that traverse interstellar space for millions of years, maintaining their functionality and awaiting activation triggers. Atlas's apparent dormancy during its journey, followed by its sudden activation, aligns perfectly with this profile. A time crystalline power core could sustain minimal operational systems indefinitely. This would involve just enough processing power to monitor sensors, track its position, and calculate its trajectory, followed by a ramp up to full operational capacity when sensors detect appropriate environmental conditions, such as proximity to a star or specific electromagnetic signatures indicative of a technological civilization. We are currently viewing Atlas through the lens of conventional physics and engineering assumptions which are based on our limited experience with space exploration. However, it might be operating on principles that we are only just beginning to glimpse in our most advanced laboratories. The very fact that we are discovering these principles suggests that they are not impossibly exotic, but rather represent an advanced stage of development. They signify a higher rung on the technological ladder, one that any sufficiently persistent scientific civilization would eventually ascend. And if we are already making progress towards understanding some of these principles, what other advancements might be within our reach? What other technologies are we currently developing that might have extraterrestrial parallels? What capabilities could we achieve in the next century that would appear as mere magic to us today? As it turns out, we are actively working on stealth systems that bear a striking resemblance to these concepts. Part 14, China's Hypersonic Plasma Shield Patent. In early October of 2025, defense analysts uncovered a patent application filed by a Chinese Aerospace Research Institute. This filing described a plasma-based shielding system intended for hypersonic vehicles. Curiously, the details within the patent were not classified. suggesting either a deliberate disclosure aimed at intimidating rival nations, or possibly an administrative oversight that resulted in sensitive information entering the public domain. The system functions as follows. As a hypersonic vehicle travels through the atmosphere at speeds of Mach 5 or greater, the extreme aerodynamic friction generates heat, transforming the surrounding air into plasma at temperatures of thousands of degrees. This creates a luminous sheath enveloping the vehicle. This plasma inherently interferes with radar signals, thereby diminishing the vehicle's detectability. However, it also precipitates communication blackouts, impedes thermal imaging, and exacerbates structural heating issues that engineers have grappled with for decades. The Chinese patent outlines the utilization of electromagnetic fields to sculpt and stabilize this plasma sheath, effectively transforming a problem into a strategic advantage. Magnetic coils generate fields that precisely shape the plasma into specific configurations, creating zones of dense ionization that actively deflect incoming electromagnetic radiation, thereby functioning as a formidable force field against radar and directed energy weapons. The technical specifications indicate a multi-layered approach, employing different field geometries optimized for various threat profiles. Against radar detection, the plasma generates a diffuse, continuously shifting surface that scatters incoming waves in an unpredictable manner. In the case of laser weaponry, the ionized particles absorb and disperse the coherent light before it can concentrate sufficient energy to compromise the vehicle's hull. This represents an elegant application of physics for defensive purposes. The patent further extends this concept to potential applications in space, not solely within the atmosphere. By deploying similar magnetic field generators on a spacecraft and seeding the surrounding space with ionizable gas, such as xenon or argon released from onboard reservoirs, an artificial plasma bubble can be created. This bubble would scatter radar, absorb laser strikes by ionizing the beam before it reaches the hull, and could potentially disrupt particle beams or electromagnetic pulses. While it may not replicate the advanced starship shields depicted in science fiction, it would not stop physical projectiles. It offers remarkable effectiveness against electronic warfare and directed energy threats. Furthermore, the patent suggests that this technology is sufficiently mature for testing, and possibly already deployed on experimental platforms. The implications for aerial combat, satellite protection, and even asteroid or comet interception missions are profound. However, there is another implication that individuals within the defense community are reluctant to voice openly. If China is developing plasma shields for spacecraft, it is plausible that existing extraterrestrial objects might already be equipped with them. Envision Atlas enveloped by a thin layer of ionized gas, sustained by internal magnetic field generators. This plasma layer would impede our ability to characterize Atlas spectroscopically from a distance. Light passing through plasma undergoes scattering, absorption, and re-emission at varying wavelengths. Spectral lines become blurred, and emission features are obscured. What we currently interpret as faint and inconsistent cometary activity might, in fact, be a sophisticated stealth mechanism, a plasma shield modulating the escape of electromagnetic radiation, rendering Atlas less luminous and more erratic than its actual state. The detected hydrogen cyanide might represent only a small fraction that manages to penetrate the shield, while the majority of emissions are trapped, ionized, and managed by the shielding system. This would explain why Atlas appears dimmer than its indicated gas production rate would suggest. It is not that Atlas possesses an unusually low reflectivity. Rather, we are observing it through a deliberately engineered obscuration layer that controls the information reaching our telescopes. The Chinese patent also references the use of plasma shields to provide protection against hypervelocity impacts, small particles travelling at orbital speeds. In space, even minuscule debris can penetrate metal at such velocities. A plasma shield would not vaporize incoming debris, but it could ionize surface layers, subtly deflecting the particle or diminishing its effective mass through the ablation of its outer shell. For a probe like Atlas, traversing interstellar space for centuries or millennia, micrometeoroid impacts pose a significant hazard. Over thousands of years, countless collisions would relentlessly degrade even the most robust materials, damaging solar panels, pitting optical sensors, and potentially compromising structural integrity. A plasma shield would serve as excellent armor, preserving the probe's integrity through an immense number of collisions. Moreover, if Atlas is equipped with such shielding, it might intensify its activation as it approaches the Sun, offering protection against heightened solar wind flux and radiation. We would observe this as increased plasma emission, which we would interpret as cometary activity, without suspecting that it is, in reality, defensive technology escalating its response to environmental threats. The system would operate autonomously, adjusting its shield strength based on sensor data regarding particle density and radiation levels. Now, let us delve into a more conspiratorial line of thought. The timing of this Chinese patent filing, in October of 2025, is particularly intriguing. Atlas initiated its hydrogen cyanide emissions in September of 2025. Within a matter of weeks, China publicly filed a patent for plasma shielding technology that coincidentally offers a plausible explanation for some of Atlas's anomalies. Is this mere coincidence? Perhaps. Or it might be that individuals within Chinese aerospace, who are tracking Atlas through military telescopes with superior resolution compared to civilian instruments, observed characteristics suggestive of plasma shielding. It is conceivable that they reverse-engineered the concept. Alternatively, they might have been independently developing this technology and recognized Atlas as validation for their approach. Regardless, the patent filing serves as a signal to other nations. We're aware of what is out there. We understand the technology, and we are developing countermeasures. It functions as a geopolitical announcement cloaked in technical documentation. Furthermore, it implies that classified observations of Atlas might be far more detailed than anything that has been released to the public. Consider the capabilities of military-grade space surveillance systems. Civilian telescopes monitor brightness, trajectory, and spectral signatures. Military systems, however, incorporate infrared monitoring, analysis of electromagnetic signatures, and even detection of gravitational microlensing effects. If Atlas is generating magnetic fields potent enough to contain plasma, those fields would be detectable by sensitive magnetometers. If it is releasing ionizable gas, spectroscopic analysis might reveal isotopic ratios that are inconsistent with natural cometary processes. Military analysts may have detected these anomalies months ago, compiled them into classified reports, and commenced work on countermeasures without ever informing the public. The Chinese patent could be an integral part of this covert technological competition, a strategic move to assert priority and signal capability. A more ominous scenario exists. What if plasma shield technology is not solely defensive in nature? What if it possesses offensive capabilities? A sufficiently powerful plasma bubble, energized by electromagnetic fields, could function as a directed energy weapon. By shaping the fields to concentrate the plasma into a beam, a superheated jet could be generated, capable of cutting through materials, disrupting electronic systems, or even affecting biological tissues. If Atlas is equipped with such a system, the hydrogen cyanide cloud might represent a secondary threat. The primary threat could be electromagnetic in nature, a plasma weapon activated at perihelion when solar power is at its peak, targeting Earth or our satellites with an energy burst against which we are entirely unprepared to defend ourselves. Our current detection methods would be incapable of anticipating such an event. We are looking for kinetic impacts, gravitational perturbations, and overt weaponry. We are not monitoring for subtle electromagnetic buildups or magnetic field anomalies around Atlas, because we mistakenly believe it to be a comet, and comets do not carry weapons, except, perhaps, this one does. The underlying physics would operate as follows. At perihelion, the solar flux provides the maximum energy for power generation. Atlas could charge capacitor banks, energize its magnetic field generators to their highest output, and release a substantial quantity of ionizable gas. The magnetic fields would compress and accelerate the plasma, generating a focused beam with temperatures exceeding those of the Sun's surface. Directed at Earth, such a weapon would not need to penetrate the atmosphere. It could target satellites, communication networks, and GPS infrastructure. A single discharge could disable hundreds of satellites, crippling modern civilization's reliance on space-based technology. Furthermore, because the plasma would dissipate rapidly after discharge, forensic analysis would prove exceedingly difficult. We might never be able to definitively prove that it was a deliberate act rather than a natural phenomenon. The development of plasma shield technology, both in China and presumably in the United States and other nations that are not publicly disclosing their research, conveys a significant message. We are entering an era where space is becoming increasingly militarized, where stealth and electronic warfare extend beyond Earth's atmosphere, and where the distinction between civilian and military space assets is becoming blurred. In this context, an object like Atlas becomes a critical test case. How do we defend against something we do not fully comprehend? How do we ascertain its true nature without provoking it, if it is indeed capable of being provoked? How do we coordinate international responses when nations are actively competing for technological advantages? These are not merely academic inquiries. They are operational dilemmas that space agencies and military organizations are currently grappling with behind closed doors in classified briefings. And as they deliberate, Atlas continues its inward trajectory, approaching perihelion and drawing closer to whatever programmed objective it is designed to fulfill. However, here's the fundamental truth about secrets and classified observations. Eventually they become impossible to conceal as technology itself evolves to perceive what humans cannot. And this is where our narrative takes perhaps its most peculiar turn. Part 15. The AI Astronomer That Never Sleeps. In the arid expanse of Chile's Atacama Desert, at an elevation of 2,600 meters, where the air is rarefied and the night skies are among the clearest on Earth, a novel type of observatory commenced full operation in July of 2025. It bears no evocative name like Hubble or James Webb. It is designated the Autonomous Transient Detection Array, or ATA for short, and it represents a fundamental paradigm shift in our approach to observing the cosmos. The ATA comprises 40 small telescopes, each equipped with a 40-centimeter aperture, arranged in a grid spanning several acres. Individually, none of these telescopes would particularly impress a professional astronomer. However, collectively, through fiber optic connections to a central AI processing cluster, they form an entity of unprecedented capability. This is an observatory that functions entirely autonomously, without any human intervention, 24 hours a day, every single night. It automatically selects targets, captures imagery, analyzes data in real time, and flags anomalies for subsequent investigation. The artificial intelligence system governing the ATA was trained on decades of astronomical data, enabling it to recognize celestial objects such as stars, galaxies, supernovae, variable stars, and asteroids. Essentially, all that's considered normal. Its primary function is to detect anomalous transient events that deviate from established categories. This includes phenomena such as a star suddenly increasing or decreasing in brightness, an object exhibiting an unexpected trajectory, or a spectral signature that does not correspond to any catalogued source. When the ATA identifies an anomaly, it does not await the review of the data by a human astronomer days later. Instead, it immediately redirects multiple telescopes to that specific target, capturing follow-up observations across various wavelengths and compiling a time series dataset within minutes. Should the peculiar readings persist, the Automated Transient Detection and Analysis System, or ATDA, amplifies its response. It disseminates alerts to a network of astronomical observatories, soliciting supplementary observations, and then meticulously compiles an exhaustive report. The entire sequence, from the initial recognition of an anomaly to the orchestrated follow-up, unfolds with a swiftness that surpasses any human-driven mechanism. This artificial intelligence is impervious to fatigue, distraction, or the need for committee consensus to alter observation schedules. Within its inaugural 3 months of operation, ATDA catalogued 17 transient cosmic events that had eluded detection by other survey programs. The majority of these proved to be familiar celestial phenomena observed from unconventional vantage points or at unexpected junctures. However, 3 instances presented as unclassified entities or occurrences that existing astronomical frameworks could not adequately elucidate. One such event involved a rapid luminosity surge in a star previously documented. Its brilliance escalated by a factor of 50 in a mere 6 hours, subsequently diminishing back to its normal state over a 2-day period. No recognized stellar variability mechanism produces such a light curve. It was not a supernova, no spectral signatures indicated the fusion of elements. Nor was it an eclipsing binary system. The timing and symmetry of the event were incongruous. It simply flared and subsided, reverting to its baseline state without any apparent cause. ATDA classified this as anomalous, archived the associated data, and continues to monitor the star, awaiting any recurrence. The second unclassified phenomenon was an object traversing the asteroid belt with an unpredictable path, exhibiting minor velocity alterations that defied explanation through gravitational influences from known celestial bodies. Had to track this object for several nights, determining that its trajectory was non-Keplerian, meaning it was not adhering to a simple orbit dictated solely by the Sun's gravity. Some external force was perturbing it. This could have been an as-yet undiscovered asteroid passing in close proximity at a precise moment, an astronomically improbable coincidence, or the object itself was actively maneuvering. ATDA flagged this for human examination. By the time astronomers analysed the information and requested further observation, the object had moved into a sector of the sky, obscured by the dense stellar field of the Milky Way's galactic plane, effectively vanishing into the background. It has not been reacquired. The third event remains under scrutiny. It pertains to a spectral line detected within a distant galaxy that does not align with any known element or molecule. While it could be an instrumental artifact, a defect in the spectrograph, the line consistently appeared across multiple exposures captured by different telescopes within the array, diminishing the likelihood of a mere glitch. If genuine, it represents either a novel quantum transition previously unobserved or emissions originating from something absent from our current periodic table. Now, consider the implications of ATDA. It is a machine intelligence meticulously surveying the cosmos, sifting through the mundane to spotlight the extraordinary, operating ceaselessly without the inherent biases, preconceived notions or limitations of human astronomers. And here lies the disquieting aspect. What if entities such as Atlas, or perhaps probes dispatched by non-human intelligences, manifest their signals and behaviours in ways specifically designed for machine detection rather than human perception? What if the communication strategy of a highly advanced civilization presupposes that any other technologically capable species would eventually develop AI observers, and that these AI systems would be capable of discerning patterns that organic minds overlook? We humans tend to search for what is familiar: stars, planets, comets, galaxies. Our innate pattern recognition is shaped by evolution and cultural conditioning. An AI, however, trained purely on data without any preconceptions about what ought or ought not to exist, might perceive phenomena entirely invisible to us. Atter's identification of the non-Keplerian asteroid is particularly pertinent to the Atlas situation. Imagine that other Atlas-like objects exist, smaller, fainter, exhibiting subtle evasive maneuvers. Human astronomers might not prioritize them, assuming any trajectory deviations are attributable to outgassing, the Yarkovsky effect, or observational errors. Conversely, An AI specifically programmed to identify non-Keplerian motion would detect them instantly. ATDA might already be registering a population of artificial objects within our solar system, flagging them as anomalies, yet these alerts reside within databases awaiting human scrutiny. And humans are inherently slow, creating a significant bottleneck. The AI registers reports and then waits while we engage in debates, convene committees, submit grant proposals, and draft formal requests. Meanwhile, these objects continue their operations unimpeded by our ponderous response. This presents a philosophical quandary that is deeply uncomfortable. What if the universe has been attempting to communicate with us for decades, even centuries, transmitting signals, deploying probes, leaving behind evidence, but we were incapable of perceiving it because our observations were filtered through human senses and human assumptions. And now, finally, we have engineered artificial eyes, AI systems that perceive differently, that recognize patterns beyond our comprehension, and these systems are beginning to notice what has been present all along. ETA represents merely the vanguard. Other AI-driven observatories are in various stages of development or planning. Machine learning algorithms are being integrated into existing telescopes, into orbital observatories, and into radio telescope arrays. Within the span of a decade, the majority of astronomical observations will be mediated by AI, with humans relegated to supervisory and interpretive roles rather than as primary observers. In this transformative period, we may discover that the cosmos is far more intricate and far more inhabited than we ever dared to imagine. This shift will not be due to a change in the universe itself, but rather because we have finally acquired the means to perceive it accurately. Atlas aligns uncomfortably well with this unfolding narrative. Its anomalies, the sudden activation of hydrogen cyanide, the anti-tail phenomenon, and the erratic brightness, are precisely the kinds of characteristics an AI observer would highlight. A human astronomer might readily dismiss them as mere cometary peculiarities, but an AI trained to identify deviations from natural behavior would elevate Atlas to a highly anomalous status, demanding intensive follow-up investigations. And if ATA had been operational when Atlas was farther from Earth, in a dormant and faint state, would the AI have detected it earlier? Would it have flagged Atlas as suspicious prior to its activation, based on subtle trajectory deviations or spectral signatures imperceptible to human analysis? We will never know, as ATDA commenced operations only after Atlas had already garnered significant attention. However, future Atlas-like objects will not share this advantage. The AI will be actively observing, learning, and refining its detection algorithms based on the insights gleaned from this case. Consequently, the era of covert probes, of objects stealthily navigating the solar system unnoticed, is drawing to a close. We are entering an epoch of machine-mediated transparency, where artificial observers perceive everything, categorize everything, and leave nothing unexplained for an extended duration. Yet, this transparency is a two-way street. If AI observatories detect artificial objects, who assumes control over that information? ATDA receives funding from a collaborative alliance of academic institutions and governmental agencies. Its data is technically accessible to the public, but established protocols permit the withholding of discoveries pending peer review, national security assessments, or international coordination. Should ATDA detect something genuinely alarming, something that substantiates Atlas's artificial nature or reveals additional probes, will that data be immediately disseminated to the public, or will it be classified, routed through intelligence channels, and released only after authorities deem the populace ready? The AI does not make this determination. Humans do. And humans, as evidenced by Psyche's blackout and ES's data dissemination delays, possess a propensity to control information when they fear public reaction. Thus, here we stand in October of 2025, observing Atlas as it approaches perihelion. We are aware that AI systems are scrutinizing the celestial sphere with capabilities exceeding human perception, cognizant that governmental bodies and space agencies are withholding data they have not shared, and informed that fusion energy ventures are faltering while black holes drift unseen through the galaxy, and quantum time crystals are transitioning from theoretical concepts to laboratory realities. The current context transcends mere astronomy. It is deeply entwined with technological advancement, political maneuvering, and existential considerations. Atlas serves as the focal point, an object that converges all these disparate threads into a singular narrative. And this narrative is rapidly approaching a conclusion that remains obscured from our view, yet we sense its imminence, much like an approaching tempest. The fundamental question is not whether Atlas is artificial. The critical inquiry is what will transpire once we can no longer deny its nature. What will happen when the AI observers accumulate sufficient data? When the anomalies accumulate to such an extent that even the most recalcitrant scientist is compelled to acknowledge that conventional natural explanations are profoundly inadequate? What will occur when Atlas reaches its closest approach to the Sun in late November? When solar power reaches its zenith and whatever its intended function is becomes unavoidable? Do we possess a contingency plan? Have governments established protocols for this scenario? Or are we improvising, clinging to hope, treating an existential threat as a bureaucratic inconvenience to be managed through committee meetings and official statements? I possess no definitive answers to these questions. No one does. We are navigating uncharted territory, guided by instinct and incomplete data, observing an object that might represent the most significant discovery in human history, or it may simply be an unusual comet that coincidentally exhibits every anomaly we would anticipate from an artificial probe. The inherent ambiguity is agonizing, the uncertainty is deliberate, and the reticence from authorities, the absence of transparency, the meticulous management of information flow, suggest they are as perplexed and apprehensive as we are. Nevertheless, they are committed to maintaining the facade of control, perpetuating the illusion that they comprehend the situation and have it firmly in hand. However, this much I know with absolute certainty. The universe is indifferent to our illusions. Atlas is real. Its trajectory is predictable. Its emissions are measurable. Its behavior is observable. And whatever it is, whatever its purpose, we will discover it soon. Perihelion is mere weeks away. The hydrogen cyanide cloud continues its expansion. The AI observatories persist in their vigilance. And somewhere within classified briefing rooms and emergency planning sessions, individuals with access to information beyond our reach are formulating decisions that will impact us all. These decisions will dictate our response, whether to apprise the public, whether to initiate action, or adopt a wait-and-see approach. We have peeled back the veil surrounding Atlas. We have exposed its anomalies, connected the disparate pieces of evidence, and posed the questions that urgently required addressing. However, the cosmos does not offer a reset button. One cannot unsee what has been revealed. One cannot feign normalcy once the underlying pattern has been glimpsed. Therefore, observe the skies, not merely with your eyes, but with the profound realization that what you perceive may not be the unvarnished truth. Watch for the moments when official narratives undergo a subtle shift. Witness when skeptics abruptly transform into believers, when data that should be publicly accessible is inexplicably classified. Be vigilant for indicators of clandestine activities, for preparations being made for scenarios that are deliberately kept from public discourse. Observe Atlas as it progresses inward, whether it brightens as expected or not, whether its behavior conforms to predictability or deviates sharply, whether it proves to be the comet we hoped for, or reveals itself as something far more formidable, something we had feared. And recall that the universe is vast, ancient, and replete with phenomena beyond our current comprehension. Atlas may represent merely the initial instance, the first object we have detected due to our technology finally reaching a level of sophistication sufficient to identify anomalies. How many others remain dormant, patiently awaiting their moment, observing us? How long have they been present? And what will transpire when they all awaken? These are the questions that haunt my sleepless nights, causing me to stare at the ceiling, contemplating whether tomorrow will be the day when everything irrevocably changes. The evidence is compelling, the temporal sequence is evident, the threat is tangible, and the silence emanating from those who possess the most critical knowledge serves as the most potent warning of all.